Hi again and welcome along to number 3 in our podcast series all about sound. Today we're going to look into how sounds travel in solids, liquids and gases. Now, we already know all about solids, liquids and gases and what happens to them in different situations, including when we heat them and when we cool them. These things, like boiling, happen because energy is transferred by the particles as they vibrate and bump into each other. In a similar way, sound waves can be transferred along particles as they vibrate. Take a look at this experiment from my lab. A bell jar with a little bell in it, you can hear it ringing there, and a vacuum pump. Okay, so at the moment in my bell jar we're full of little air molecules. So when I make a sound, okay, those molecules can vibrate and pass the sound on so that we can hear it. But if I take all of the air away, I wonder if we'll be able to hear it at all. So my vacuum pump's going to take all the air out of here. And it takes a little while, so we're going to leave it to take all the air out. Well, we can just about hear it, so there's still some air in there. I'll keep going. And there we go, can't hear the bell anymore. Okay, so there's no air molecules left in there anymore, and now when we ring it, can't hear the bell. But if I put the air back in, and I'm switching my pump off, okay, we can hear the bell again. So we can see that sound can only travel through a medium or a substance, and not through a vacuum or an empty space. So, sound can travel through different substances. But does it travel at different speeds through these substances, like solids, liquids and gases? To answer this question, we need to think about how the particles are arranged in solids, liquids and gases. In solids, the particles are all very close together, in a fixed position, and vibrate, bumping into each other easily. In liquids, the particles can move around a little bit more, but they can still vibrate and bump into each other quite easily. In gases, the particles are far apart and random. They can still vibrate and bump into each other, but this happens much less often than it does in liquids, and far less often than it does in solids. So sounds will travel fastest in materials where the particles are close together, and so they're more likely to bump into each other and pass their vibrations on. Therefore, sounds travel faster in solids than in liquids, and they travel faster in liquids than in gases. Sound travels through air at 343 meters per second. Sound travels through water at 1500 meters per second. And sound travels through steel at 5100 meters per second. So sound is much quicker in solids than it is in liquids and in gases. Knowing how sounds travel has led to many technological developments, including me having a lovely telephone in my lab. Hello? No, I'm sorry, I don't know who you're asking for. Who's this? No, they don't work here. What number did you call? I see where you've gone wrong. This is 0800 Tim Can. Yes, you've gone wrong. Oh, okay then. Alright then. Have a nice day. Bye-bye. Okay, bye-bye.